Let's delve into the world of education technology analytics. It's all about transforming educational data into insights that can be put into action. Education technology analytics is the systematic collection, analysis, and interpretation of educational data. The purpose is to improve learning outcomes, optimize how well an institution performs, and make decisions based on evidence. Let's explore the learning analytics framework. The first component is data collection, which involves gathering information from various sources such as learning management systems, assessments, and engagement metrics. Next comes processing and analysis, where statistical techniques, machine learning, and pattern recognition are employed to make sense of the collected data. Finally, we arrive at actionable insights, which include personalized recommendations and predictive modeling to improve learning outcomes. The flow starts with raw data, which is then passed to analysis stage. Finally, based on analysis, important decisions can be taken. Now let's focus on student performance data collection. Some of the data sources are learning management systems, assessment platforms, digital learning tools, student information systems, and survey and feedback systems. The collection methods include real-time tracking, which involves continuous monitoring of student activities and engagement. Automated capture, which includes system-generated logs and interaction data. And periodic assessments, which involves scheduled evaluations and progress checkpoints. Let's explore the key performance metrics in education technology analytics. We can broadly classify them into academic performance and engagement indicators. Under academic performance, we have grade point average, assignment scores, completion rates, and time to completion. For engagement indicators, we look at time spent on the platform, activity frequency, discussion participation, and attendance patterns. Let's explore a performance analytics dashboard. It provides a student performance overview. Some of the key widgets include average performance, number of active students, completion rate, and average study time. The dashboard also features a performance trends chart. Key features are real-time updates, custom filters, export reports, and an alert system for at-risk students. Let's explore predictive analytics and early warning systems. The prediction model involves a few steps. It starts with historical data analysis, where past performance patterns and behavioral indicators are examined. Next comes risk assessment, where machine learning algorithms are used to identify students who are at risk. Finally, early alerts are generated to provide automated warnings before academic failure occurs. Some of the intervention strategies are personalized outreach, adaptive learning paths, peer mentoring, and resource allocation. Let's discuss enrollment analytics and retention patterns. Some of the enrollment trends to look at are demographic analysis, program popularity, seasonal patterns, and conversion rates. For retention analysis, some important parameters are first-year retention, program completion, risk indicators, and improvement strategies. The average retention rate is 85%, and the completion rate is 78%. Let's explore resource optimization analytics. This includes both faculty and infrastructure analytics. For faculty analytics, it is important to monitor workload balance, track performance, and engage in capacity planning. For infrastructure analytics, we want to optimize space utilization, manage technology resources, and improve energy management. It's important to discuss privacy and ethics considerations. For data privacy, some important factors are data protection, consent management, data anonymization, and access controls. For ethical use, it's important to consider algorithmic fairness, purpose limitation, transparency, and student agency. Let's discuss the implementation strategy and best practices. The implementation roadmap includes establishing a secure data infrastructure, deploying an analytics platform, running pilot testing, and scaling to a full deployment across the institution with training. Some best practices include stakeholder engagement, start small, training programs, and a process of continuous improvement. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.